Good morning, everyone. So, for today video, we will be wrapping the linked list, and I'm very happy to saying this. So, we have done two hard problem. Our first problem is clone a linked list with next and random pointers. So, the problem says that we have given a linked list, and in this linked list, we have simply every node is connected to their next node, and every node have also a connection that is with the random links. First node is connected to be the null pointer, or second node may be connected to the third node or first node. So these are the random pointers. So our linked list have two next node basically. One is their adjacent next node and one is the random node. So for solving this question, firstly I have used the concept of map, where I have stored the firstly for this problem. Our workflow be firstly I initialize the temp with the head, and as moving up to the tail, I am putting all the elements in the map. And for the elements, I mean that we have a normal actual node and a copy node. So actual node stores the actual value, while we are making the same node's copy and storing both of them in a pair set. So that's how we are putting all the elements. After taking all the elements in the map, we again make our temp to our head and runs the loop while it and shows to null. And in this, we simply put the value of that node into the map. And after that, our copy node's next pointer points as similar as the our given nodes next. And same for the random nodes. Our copy nodes random is connected similarly as given as our present actual nodes random pointer. So that's how I have solved this problem. So for this, the complexity reaches to big O of 2n, as we are running two loops. First loop for traversing all the values in our map, and second node for mapping our new copy nodes. So that's how our complexity reaches to big O of 2n. And for this solution, we are also taking extra space. So we are taking the extra space of big O of n for the maps. And basically it is big O of 2n because we are storing two values, the actual node value and the copy node value. So hence this questions, it's the brute force, not the optimal one. So for the optimal solution, we will do some optimizations. So I have divided the task into three different parts. So our first part is to make sure that the given linked list in the given linked list we will be attaching one more new node in between two adjacent nodes. So and that node will be the copy of their previous node. So if our head is like 7, so and next node is 13, so we will be putting a new node in between the 7 and 13 node, and that will be initialized as 7. That's our head or temp. So that's the first part. And after making sure that our next pointers are connected, like uh, our actual node's next pointer is showing to next node, but now our task is to make the new connections, like our current new pointer should should points their next new node that is in between their adjacent nodes. And after this, we will be connecting our new pointers next node to their next node, that will be the next node of our actual node. So we will be running the loop for this until we reaches to the tail. Our first task will be to make the copy of that node. For every node we will be making a copy, and after that we will be connecting them to their next node. And After this, we will be initializing a dummy node, and once again we will run the loop, and in this loop we will be connecting the random pointers of our actual node as like our actual node to our copy nodes. So our copy nodes random pointer will also connect, as now we have a separate linked list. So first task is to make a copy node in between the adjacent element. Second task is to separate that new copy node list, and third task is to connect their random pointers. And after that we will be returning the dummy's next node, that will be our new copied node's head. And that's how our problem gets solved. And here we have not used any extra space, so complexity reaches to big O of 2n and space complexity reaches to big O of 1. So that's how I solved that problem. So coming up on our next and last problem of linked list. So it is the design of browser history. So as we know that in our browser there are multiple functionalities, like we opens the tab and we our mostly tabs are connected. So in this we are using the concept of linked list, where we visit the node and we go forward and we goes backward. So that's how our task will be like visiting the home page, and to visit the new next page, to visit their next page or next page, or come backward to their actual back page. And that's how we will be moving. That will be like a surfing of browser in multiple tabs, so we are making the linked list for that. So here basically three major functionalities. First is to make the home page our to make the home page node, and second is when we are going to forward of our nodes, and third is when we goes backward to our nodes. So we will be making the class browser, where we have a current node, and browser will be connected to our home page, and our current node will show this new node of home page. So while visiting the URL, we should remember that we will be creating a new node. There will be a new tab. Always if we opens our Chrome in the starting, it shows a new tab. So for that we will be making a new node, and that will be our current node, and current node dot next is equals to next node, and current will be shows to next node. So when we attach this new node and we are switching to the next step, so basically we are making our current pointer to goes on the next pointer. So that's how we will be making the home page. And coming upon, if there are multiple tabs and we are going backward in our linked list, or we should say that we are just removing all the new tabs and going back to our home page, or maybe we are cutting that also, so there will be a edge case also. So for this we will be making a function of steps, while steps goes and steps means number of tabs that we are going to be linked, and we are going to remove them or going back in the tabs. So either we will be deleting the tabs or we will be just moving backward. So for example, first of all I should give the example. Like if we open the Facebook app, so first of all how we open the app, first of all we goes to the Chrome, we opens the new tab, we search the new tab as facebook.com, so that's our home page. After that we log in the tab, and in that tab we goes inside the tab. After logging in, we goes to the new tab, and in this new tab we surf it, or we moves to the new, maybe we goes to into the setting, and then in the profile page picture, and in this edit option. So we are in a linked list where every tab is linked together, and we can simply move backward or forward. It's a doubly linked list. And for this we cannot jump directly to the home page or back. There will be a process, like either we will be able to go backward one by one step, or we will be able to go forward by one step. We cannot jump directly. So for the back steps, we will be running the loop while the steps goes end. Our if currents back is available, suppose there is a test case, or there is a case that where we have a single tab and there is not a back tab now available. So for that case, we will be going to be a break pointer, and if it is not available, suppose we have initialized for the 5 step and we have 3 tabs available, so basically it will end when it reaches to the 3. So for this, we will be checking condition if currents back is available. If it is available, then current goes to current back, or else and step goes minus, of course. So that's for the back case, and if it is not available, so we will just break down and goes to the final tab and returns the value. And same for the forward steps. uh, while our steps count is maintained, we will be checking if there is current front is available or not. If current front is available, so our current goes to their current next pointer or current front, and if it is not available, we will just break down the loop and comes down from that, and steps goes minus minus, and at the end we will be returning the currents data. That will be the that particular tab which we want to see. Either it may be a home tab, or maybe a visited Google's or visited tab. So this is the question of designing a browser history question. So with this, our for the complexity, our complexity will be depending upon the steps. How much number of tabs are we opening or closing? So on that, big O of steps will be the complexity for forward, and big O of steps will be the complexity for backward. Suppose we are taking n steps and n steps forward and n steps backward. So we are overall complexity reaches to big O of 2n. So that's how we will be able to solve this browser history question. And with this video, our linked list journey ends here. And in our upcoming videos, we are going to start stack and queue. I have already told that we are targeting to complete it by the end of our November. So we will be completing. Until that, stay tuned, stay happy, and be consistent. Thank you.